Hi friends, welcome to GMK tutorials. So in this video, we are going to write a Verilog code for the D-Flipflop. Okay. So previously we saw the SR flip-flop. Now we are going to focusing on D-Flipflop. So let us say here. So D-Flipflop can be achieved by tying the yes and ఆర్ వాల్యూ. సో మనకి ఎస్ఆర్ ఫ్లిప్ ఫ్లాప్ లో ఉన్న ఎస్ వాల్యూని అండ్ ఆర్ వాల్యూని అంటే ఎస్ వాల్యూ ఐ మీన్ సో జస్ట్ కాంప్లిమెంట్ ఆఫ్ ది R value is the complement of S. Just if you are applying like this, we can get the D flip flop. So for this purpose, it is a code module D flip flop, input D, input clock, Q and Q bar. So here SR flip flop, we can call the SR flip flop module name and D. So actually, I mean, in case of SR flip flop, S and R value, but instead of S and R, just we are giving the one value and the second value is a complement of the first one. So here D and complement of D clock Q bar. So it makes a just if you want to run this program compulsory you have to include the file of SR flip. So for that purpose I have to mention include SR flip flop file also. Okay, by executing this one we can get the D flip flop output. So let us see first we can check the syntax. So just that is one important point is nothing but D flip flop can be achieved. S and R values are complement of each other. Then we can get the result. That result is exactly equal to the D flip flop. So D flip flop means that the output of the flip flop is equal to the input of the value, right? So that is the important thing, right? So let us see. This is also correct. Coming to the simulation point of view. Is flip flop that is nothing but D flip flop. D flip flop test bench. Just I can increase the screen size. So let us see here. So D flip flop test bench name D comma class. So because of D can be used as a left side variable, so it must be a register type variable also. Clock is the input and wire and Q and Q bar are the output variables. So instantaneous name of D flip flop and D is equal 0, clock is equal 0. So that means initially no responsibility. When D is equal to 1 means that whenever the clock must be high. So clock high undi kabatti obviously output of the Q is equal to 1. So clock is also high, input is equal to 0. Therefore output is equal to Q is equal to 0. So this is the test bench. And whenever the clock input is high, at that time the output of the flip flop is equal to the input. So that is nothing but D flip flop. D flip flop means that data flip flop. Data flip flop means that simply output is an exactly equal to the input value when the clock value is high. So let us see how the waveform is. Let us see. Clock is equal to 0. When the clock is equal to 0, flip flop cannot be processed with the values. So see here, when the clock is equal to 1 means that the flip flop is in good condition. At the time input value is equal D is equal to 1. Therefore output value Q is equal to 1. Q bar is equal complement of that one, right? So here see the situation, clock is equal to enable, D is equal to 0. So D is equal to 0 means that input 0, output is also 0 and Q bar is a constant. So it verifies the D flip flop operation, right? I think it is very understanding. So if you want to write this code for that one, compulsory you have to write the SR flip-flop code. That is very important, right? Whenever you are including the SR flip-flop, at that time only it is working condition because of we have to mention SR flip-flop criteria also. So compulsory you have to write the SR flip-flop input consideration also. Okay. So this is regarding the D flip flop. I hope this video is very clear for you. I think. Thank you.